Your car will rust. Your house will need constant repairs. Everything you own has a planned expiration date. But there's concrete in Rome that's been standing for 2,000 years, and it's getting stronger. There are clocks that ran for 700 years with no batteries. Windows we literally cannot rebuild. Machines that multiplied human strength 60-fold using only rope and wood. We've been sold a lie. That progress is linear, that everything modern is better, that our ancestors were primitive. But what if medieval peasants built better than modern engineers? What if ancient Romans understood material science we're only now rediscovering? Today, we're reverse engineering 12 ancient technologies that expose an uncomfortable truth. Planned obsolescence isn't just a business strategy. It's the reason we've forgotten how to build things that last. This is going to challenge everything you think you know about progress. Building for eternity. While we're examining Roman engineering genius, here's a secret that puts our modern construction to shame. Roman concrete structures from 2,000 years ago still defy earthquakes and ocean waves. While our modern buildings crumble within decades, the Romans discovered something we're only now beginning to understand. They created self-healing concrete. Their secret ingredient was volcanic ash from Mount Vesuvius, which created a chemical reaction that literally repairs cracks as they form. When seawater enters a crack, it reacts with the volcanic minerals to grow new crystals that seal the damage. This is nanotechnology that occurs naturally. Recent analysis shows that Roman concrete gets stronger over time, not weaker. The lime clasts they mixed in act as microscopic reservoirs of healing agents, activated by water infiltration. It's sustainable engineering at its finest, using local materials to create structures that improve with age. But the Romans didn't stop there. They developed different concrete formulations for different purposes. Lighter pumice-based concrete for dome construction, denser volcanic concrete for underwater foundations, and ultra-strong basalt concrete for military fortifications. Each formula was precisely calibrated for its intended use, showing a level of materials science that we're still trying to fully understand. Compare this to modern Portland cement, which begins deteriorating immediately and requires constant maintenance. The Romans built for eternity. We build for profit margins and planned obsolescence. In our climate crisis, where construction accounts for nearly 40% of global carbon emissions, Roman concrete offers a roadmap to sustainable building that actually improves over time. The power of perfect friction. For centuries, the image of pyramid construction has been dominated by one thing: brute force. But that picture is incomplete. The real secret wasn't just the number of men on the ropes. It was a subtle, almost invisible mastery of physics that slashed the energy needed for the job. The tool was the sledge, but the secret was water. A famous painting from the tomb of Jehuti-Hotep, around 1900 BC, clearly shows a man on the front of a sledge pouring liquid onto the sand in its path. For years this was thought to be purely ceremonial, but in 2014, physicists at the University of Amsterdam tested it. The science behind this is fascinating. By adding just the right amount of water to sand, the sliding friction is reduced by up to 50%. The water forms tiny capillary bridges between the sand grains, making them stick together and creating a firm, smooth surface for the sledge to glide over. It's the same reason you can build a solid sandcastle with damp sand, but not with dry sand. This wasn't an accident. It was precision engineering. Too little water and nothing happens. Too much, and you create a slurry that makes things worse. The Egyptians found the sweet spot through systematic experimentation. They weren't just mindlessly pulling. They were actively engineering the ground beneath them, turning their greatest obstacle, the sand, into their greatest ally. Recent archaeological evidence suggests they went even further. Traces of animal fat have been found on some sledge runners, indicating they combined water-sand preparation with primitive lubrication. They also developed specialized wooden runners with specific curvatures that distributed weight more effectively. This was comprehensive transport engineering, not brute force dragging. Taming the elements. Long before the Industrial Revolution, ancient societies learned to capture and harness nature's raw power. The watermill represents one of humanity's first steps toward automated production, freeing people from backbreaking manual labor. While many picture watermills in medieval Europe, their origins stretch much further back. The Roman engineer Vitruvius described sophisticated geared mills around 40 BC, and the Greeks likely had simpler versions even earlier. The Greek poet Antipater of Thessalonica wrote an ode to the watermill, praising it for liberating women from the exhausting work of grinding grain by hand. The Romans deployed these across their empire for far more than flour production. Archaeologists have uncovered massive industrial complexes like Barbegal in France, a cascade of 16 water wheels that historians call the greatest known concentration of mechanical power in the ancient world. These installations processed everything from grain to textiles, using sophisticated gear trains to convert water's linear flow into rotational force at optimal speeds. But the real innovation was in their understanding of energy efficiency. Roman mill designers calculated optimal wheel diameters, paddle angles, and gear ratios to extract maximum power from available water flow. They developed overshot wheels for high-head installations and undershot wheels for rivers with strong current but low drop. Each design was mathematically optimized for its specific environment. When rivers weren't available, the solution came from the sky. Persian engineers around the 7th century AD developed the first practical windmills. Unlike the familiar Dutch designs, these were vertical axis mills that resembled giant revolving doors, specifically engineered for the arid landscapes where water was scarce but wind was constant. In northern Europe, the windmill evolved independently, adapting the same gear multiplication principles used in watermills. But European windmills added crucial innovations: adjustable sails that could be angled for different wind speeds, and automatic orientation systems that kept the mill facing into the wind. These weren't just tools, they were sophisticated examples of renewable energy engineering that operated completely off-grid. The lost machines of Herodotus. We now return to the sands of Giza to confront one of history's most intriguing puzzles. The Greek historian Herodotus, writing around 450 BC, left us a tantalizing clue about pyramid construction that mainstream archaeology still struggles to explain. He described machines formed of short wooden planks that raised stones from one level to the next. What were these mysterious devices? His description suggests sophisticated mechanical systems rather than simple ramps, a picture of precision engineering that doesn't match the conventional narrative. Of course, we must approach Herodotus cautiously. He was writing 2 millennia after the Great Pyramid's completion, and he was known to mix careful observation with second-hand accounts. Yet his words have sparked centuries of speculation. Some researchers propose that the Grand Gallery inside the Great Pyramid wasn't merely a passageway, but housing for an elaborate counterweight system designed to lift massive blocks. The gallery's precise dimensions, unusual corbelled ceiling, and series of mysterious holes might have supported a sophisticated pulley arrangement. Others point to enigmatic artifacts found throughout Egypt, grooved basalt objects that some interpret as primitive pulleys, and rope fragments showing wear patterns consistent with heavy lifting operations. There are also the curious unfinished obelisks that show evidence of sophisticated cutting and lifting preparation that was abandoned mid-process. The lack of definitive physical evidence has led many to dismiss these ideas entirely. But consider this: if the Egyptians did use sophisticated lifting machines, they would have dismantled them upon completion, recycling the valuable wood and metal components. What Herodotus may have recorded was the echo of a lost technology, filtered through generations of storytelling but preserving a kernel of mechanical truth. Recent computer modeling suggests that the internal ramp theory, where blocks were lifted through the pyramid's interior, could have worked with the right mechanical aids. Perhaps Herodotus wasn't describing fantasy, but a forgotten chapter in the history of engineering. The fire that conquered seas. The Byzantine Empire guarded a military secret so devastating that enemies called it liquid fire of the devil. Greek fire was an incendiary weapon that burned even on water, projected through bronze siphons that functioned like ancient flamethrowers. The exact formula died with its creators around 1453 AD, but chemical analysis of residues suggests it contained petroleum distillates, quicklime, and possibly sulfur or phosphorus compounds. What made it truly revolutionary wasn't just its destructive power, but the sophisticated delivery system that made it possible. The Byzantines developed hand-pumped siphons that could project streams of burning liquid up to 15 meters. These weren't crude catapults hurling fire pots. They were precision instruments with bronze nozzles, pressure chambers, and pumping mechanisms that anticipated modern flamethrower technology by over 1,000 years. But Greek fire was more than a weapon. It was a technological breakthrough in hydraulic pressure systems. The same principles that made this terrible weapon possible influenced the development of fire pumps, fountain systems, and industrial spraying equipment. Byzantine engineers understood fluid dynamics, pressure differentials, and combustion chemistry at a level that wouldn't be matched in Europe for centuries. The psychological impact was as important as the physical destruction. Enemy fleets would retreat at the mere sight of Byzantine fire ships, knowing they faced a weapon that seemed to defy the natural order by burning on water itself. The technology was so closely guarded that its operators swore sacred oaths, and the manufacturing process was kept within a single family lineage. When Constantinople fell in 1453, the last secrets of Greek fire died with the city. Despite numerous attempts at reverse engineering, no one has definitively recreated the original formula or delivery system. It remains one of history's most effective examples of technological warfare and technological loss. The impossible cuts. Prepare to have your assumptions about ancient craftsmanship challenged. We're told that Egyptians worked granite and diorite, some of the hardest stones on Earth, using copper chisels and abrasive sand. The mainstream explanation relies on immense patience and gradual grinding. But when you examine the evidence closely, this explanation starts to crack. Independent researchers point to drill cores with perfectly spiral grooves that would require feed rates hundreds of times faster than modern diamond-tip drills achieve. They highlight the boxes in the Serapeum of Saqqara, machined flat to tolerances measured in thousandths of an inch, and statues with geometric precision that challenges modern capabilities. The conventional explanation becomes even more strained when you consider the scale. The ancient Egyptians didn't just cut a few precision objects, they mass-produced them. Hundreds of granite sarcophagi, thousands of precision vessels, countless statues with identical proportions. This suggests not just individual skill, but systematic manufacturing processes. Some propose that the Egyptians developed copper hardening techniques we've forgotten, using cold working, arsenic alloying, and specialized tempering to create tools nearly as hard as steel. Others suggest they mastered advanced abrasive compounds using crushed gemstones or ceramic particles that dramatically accelerated cutting speeds. Recent experiments by engineer Christopher Dunn suggest another possibility, that Egyptians used ultrasonic drilling techniques, where high-frequency vibrations reduce cutting resistance and allow rapid penetration of hard materials. He points to specific cutting patterns and drill marks that match ultrasonic machining signatures. Still others venture into more speculative territory, proposing acoustic or chemical technologies that could soften stone temporarily. Ancient texts do describe various stone softening compounds, though none have been successfully replicated. Skeptics maintain that supreme skill, unlimited time, and known techniques adequately explain these achievements. They argue that claims of impossible precision are often exaggerated, and that we underestimate what human determination can accomplish. But for those who have measured these artifacts personally, touching surfaces that feel machine-polished and examining cut marks that suggest powered tools, the conventional explanation feels inadequate. Whether through lost techniques, forgotten tools, or systematic processes we don't fully understand, the ancient masters achieved something that continues to challenge our assumptions about primitive technology. The Earth's nervous system. Zooming out from individual monuments, we encounter a theory that ancient sites weren't isolated achievements, but nodes in a global energy network. The concept of ley lines began in 1921, when British amateur archaeologist Alfred Watkins noticed that many ancient sites could be connected by remarkably straight lines across the landscape. Watkins initially proposed these were ancient trackways, practical routes for prehistoric travel and trade, but his simple observation was soon expanded by others who suggested these lines carried subtle earth energies or telluric currents. In this view, monuments like Stonehenge and the pyramids were deliberately positioned at intersections where these energy lines crossed, creating powerful spiritual and ceremonial centers. The theory has grown to encompass a geometric grid covering the entire planet, evidence, some claim, of a lost global civilization with sophisticated understanding of Earth's energetic properties. Proponents point to the fact that many ancient sites do indeed align across vast distances, sometimes spanning continents. They also note that modern science has discovered real electromagnetic phenomena in the Earth's crust. Telluric currents, electrical currents that flow naturally through the ground, do exist and can be measured. Some researchers suggest that ancient peoples were more sensitive to these subtle energy fields and deliberately built their monuments to harness or amplify them. Mainstream science remains deeply skeptical. Geologists point out that, with thousands of ancient sites scattered across continents, finding some alignments is statistically inevitable. A pattern-seeking tendency psychologists call apophenia. There's no credible evidence that ancient cultures mapped or even perceived such a grid. Yet the concept persists, speaking to something deeper than mere pattern recognition. Recent studies of animal migration patterns show that many species do navigate using the Earth's magnetic field lines. Could ancient humans have possessed similar sensitivities that we've lost in our electronic age? Whether real or imagined, ley lines represent humanity's enduring quest to find deeper connections in the landscape around us. They suggest a worldview where the Earth itself is alive, where places have power, and where our ancestors built their monuments not just for practical reasons, but to participate in a living planetary system. The Song of the Stones. How did ancient builders lift truly colossal stones, like the 200-ton trilithons at Baalbek? When conventional explanations involving ramps and pulleys strain credibility, more extraordinary theories emerge. Enter acoustic levitation, the idea that ancients could use specific sound frequencies to neutralize gravity and float massive stones into position. This sounds like pure fantasy, but acoustic levitation is genuine science. In modern laboratories, researchers routinely use powerful sound waves to suspend small objects in mid-air, manipulating them without physical contact. The technique works by creating standing wave patterns that can counteract gravitational pull on lightweight materials. However, scaling this phenomenon up to multi-ton megaliths remains, with current understanding, physically impossible. The energy requirements would be astronomical, and no known acoustic technology could generate the necessary power levels to levitate massive stones. Yet legends of such capabilities persist across cultures, with remarkable consistency. Medieval Arab historians wrote that Egyptian builders used special chants to make stones weightless. Tibetan traditions speak of monks using precisely arranged horns and drums to levitate building blocks up mountainsides. Similar stories appear in Celtic, Native American, and South American traditions. Proponents point to the unusual acoustic properties found in many ancient sites, chambers that amplify and focus sound in unexpected ways. The Great Pyramid's King's Chamber resonates at 440 Hz, the same frequency as the musical note A. Newgrange in Ireland amplifies whispers to audible levels throughout its passages. Stone circles, like Stonehenge, create complex acoustic phenomena that modern sound engineers struggle to replicate. Some researchers propose that these sites were designed as resonance machines, tools for manipulating vibrational energy in ways we don't yet comprehend. They suggest that ancient builders understood acoustic principles that allowed them to reduce the effective weight of stones through sustained sound pressure. The physics remains dubious, but the persistence of these legends across unconnected cultures raises intriguing questions. Were these stories pure mythology, or dim memories of lost technologies that work through principles we don't yet understand? In the absence of proof, acoustic levitation remains in the realm of speculation, a fascinating what-if that challenges us to consider whether our ancestors possessed knowledge that transcends current scientific understanding. So ancient engineers mastered concrete that heals itself. They built machines that multiplied human strength 60-fold. They harnessed water and wind with precision we struggle to match. But here's where it gets even more interesting. These weren't just isolated achievements. Ancient and medieval engineers created the entire foundation of modern civilization. Medieval monks, blacksmiths and merchants weren't just surviving, they were inventing the blueprint for everything you use today. And most people have no idea. Let's expose exactly how medieval technology secretly built the modern world. Because what you're about to discover will make you question everything about progress. The first, structural engineering. Stand inside a Gothic cathedral and look up. You're surrounded by stone walls that seem impossibly thin, supporting a vault soaring hundreds of feet above your head. The whole structure appears to defy gravity. How is this possible with 12th century technology? The answer is the most sophisticated structural engineering system ever developed, a system that modern skyscrapers still use today. Medieval architects faced a seemingly impossible challenge. How do you build the tallest, most open structures possible using the heaviest material available, stone? Roman architecture relied on massive, thick walls to support heavy roofs, but Gothic architects wanted something different. Walls made mostly of glass, spaces filled with light, structures that seemed to touch the sky. Their solution was revolutionary. Instead of fighting the forces trying to destroy the building, they would redirect them. The pointed arch was the first breakthrough. Unlike a Roman semicircular arch pushing outward in all directions, a pointed arch channels forces downward more efficiently, less outward pressure on the walls. But the real genius was the flying buttress, an external arch that caught outward thrust from the main vault and carried it safely to the ground through a separate pier. It was like adding an external skeleton to the building, allowing walls to become thin curtains of stone and glass. The system was completed with ribbed vaulting, where the roof's weight was carried by a framework of stone ribs rather than solid masonry. This reduced weight while maintaining strength, the same principle used in modern steel frame construction. The result? Buildings using minimal materials to achieve maximum height and openness. Gothic cathedrals were more material efficient than Roman buildings, more structurally advanced than anything built before the Steel Age. Today's skyscrapers work on identical principles. Steel frames carry the loads like Gothic stone ribs. Curtain walls provide weather protection without bearing weight, like Gothic glass walls. External structural elements handle forces that would otherwise require massive internal supports like flying buttresses. The Gothic cathedral wasn't just a building, it was a complete revolution in structural thinking that created the blueprint for every tall building constructed since. Pure engineering genius. We're halfway through our journey. And I have to ask, are you as amazed as I am by how much medieval thinking still shapes our world? If these connections between ancient and modern technology are blowing your mind, hit that like button to help spread this knowledge. And here's what I really want to know. Which of these medieval inventions would you want us to explore even deeper? The mechanical precision of clocks? The network protocols of postal systems? Drop your vote in the comments. Your suggestions literally determine what videos we make next. History has a way of becoming a caricature. We've been conditioned to believe it's a settled story, a straight line of progress leading directly to us. When we think of the Middle Ages, what comes to mind? Mud, superstition. We call them the Dark Ages. A simple, dismissive label for a time we assume was brutish and stagnant. But what happens when that line breaks? What if that popular image is one of the greatest misconceptions we have about our own past? For 1,000 years, our ancestors faced an unforgiving world with something fundamentally more reliable than our disposable solutions. They relied on 3 pillars: ingenious design, durable materials, and a deep understanding of the forces around them. What if I told you that in this so-called dark era, engineers and thinkers created technology so profoundly advanced that even today, with all our computer modeling, we struggle to match their genius? Some secrets are lost forever. Others laid the very foundation of the modern world. Before we dive into this journey, I want to know something. Drop a comment right now and tell me, where in the world are you watching this? Your city? Your country? I'm curious to see how far these medieval secrets have traveled to reach you. Today, we journey back to an age that was anything but dark. We are counting down 10 medieval inventions so far ahead of their time that in some ways we still can't beat them. The foundation of civilization. Our countdown begins with an invention so fundamental, it literally carved civilization from the earth. For thousands of years, humanity scratched at the surface with simple wooden sticks. But medieval Europe faced a problem. The rich, clay-heavy soils of northern lands were too tough for ancient tools. The solution was the heavy plough, and it wasn't just bigger, it was smarter. Three components worked in perfect harmony. The coulter, a vertical knife that sliced through the soil like a blade through leather. The ploughshare, cutting horizontally beneath the surface. And the mouldboard, curved with mathematical precision to flip the heavy earth completely over, burying weeds and exposing fresh soil to air. But here's what makes this profound. This wasn't just about farming better. The heavy plough unlocked soils that had been useless for millennia. Suddenly, the dense forests and marshy lowlands of northern Europe became the breadbasket of the continent. Without this tool, there would be no surplus grain, no medieval cathedrals, no universities, no Renaissance. The heavy plough didn't just change agriculture, it made European civilization possible. And the engineering? Modern tractors still use the same three-part system perfected over 1,000 years ago. We've added horsepower, but we haven't improved the fundamental design. Sometimes the first solution is also the best. The three-field system. Long before sustainability became a buzzword, medieval farmers faced an existential problem. How do you feed a growing population without destroying the land that feeds you? The ancient Roman two-field system was brutal in its simplicity. Plant one field, let the other rest. But it wasted half your land every year, and even that wasn't enough to keep soil healthy. Enter the three-field system, a stroke of agricultural genius that changed everything. Divide your land into three parts. Plant one with winter crops like wheat. Plant another with spring crops like oats or barley. Leave the third fallow to recover, then rotate each year. The mathematics were beautiful. Instead of losing half your land to rest, you only lost a third. Production increased by 50% immediately. But the real genius was in the crop selection. Winter and spring crops used different nutrients and attracted different pests. The system naturally restored soil health while maximizing output. Here's what's remarkable. Modern sustainable agriculture is essentially rediscovering principles that medieval farmers perfected 800 years ago. Crop rotation, nitrogen fixing, soil conservation. We gave it new names, but the wisdom was already there. Industrial agriculture tried to outsmart this system with chemicals and monoculture. The result? Soil depletion, pesticide resistance, and environmental destruction. Maybe it's time we listen to the medievals again. The windmill post. Harnessing chaos. Wind is chaos. It shifts direction without warning, dies to nothing, then roars back with destructive force. For most of history, this made wind power a fantasy. How do you harness something so unpredictable? Medieval engineers in 12th century Europe solved this with an invention so clever, modern wind farms still can't match its adaptability, the post windmill. The entire mill house balanced on a single massive vertical post, allowing the whole structure to rotate 360 degrees. When the wind shifted, workers would push the mill around until the sails faced the breeze. Simple? Yes. Effective? Absolutely. But the real genius was in the internal mechanisms. A system of wooden gears and shafts transferred the rotation from the horizontal windmill axis to vertical millstones below. This required precise engineering to handle the massive torques involved, all crafted from wood with hand tools. The counterweight trebuchet. The starting point for our top 5 is inevitably the challenge of moving impossible weights with devastating force. Forget the simple image of a catapult powered by twisted ropes. That was a technology plagued by inconsistency, where power faded with every shot. The real challenge was this. How do you build a machine that can smash a stone wall from a quarter of a mile away, again and again, with terrifying precision, using nothing but the materials at hand? The answer, which appeared around the 12th century, was a testament to pure mechanical genius, the counterweight trebuchet, and its only fuel, gravity itself. Its principle was both brutally simple and deeply intelligent. Instead of fragile tension, the trebuchet uses potential energy. It's a massive lever. On the short end, a box filled with tons of stone. On the long end, a sling. A team would winch the long arm down, hoisting the impossibly heavy counterweight into the air, storing an enormous amount of gravitational potential energy. Then, with the pull of a pin, that energy was unleashed. But here's where the story gets truly fascinating. The true genius was in the combination of a hinged counterweight, a key medieval innovation allowing a more efficient vertical drop, and the sling, which multiplied the speed of the projectile like a whip. This wasn't just brute force, it was physics refined to a deadly art. By adjusting the counterweight or the sling, siege engineers could dial in their shots, striking the same spot on a castle wall until it crumbled. The legendary Warwolf, a massive trebuchet built by England's Edward I, was so psychologically terrifying, legend says the defenders of Stirling Castle tried to surrender the moment they saw it being built. So why is it on this list? Because in terms of pure elegant efficiency, its design is nearly perfect for its purpose. It represents the absolute pinnacle of mechanical artillery, a system for harnessing a free and utterly reliable force that was only rendered obsolete by a complete paradigm shift, gunpowder. We never surpassed it, we just changed the game entirely. The mechanical clock. What time is it? For most of history, time was a fluid, natural thing, but the idea of the hour, the minute, a standardized beat governing all of society, did not exist. The invention that took time from the heavens and put it on a tower for all to see was born in medieval monasteries. The problem was necessity. Monks needed to observe a strict schedule of prayers, day and night, regardless of the sun or weather. Sundials were useless at night, and water clocks were unreliable. They needed a machine that was autonomous and mechanical. Sometime around 1270, the first fully mechanical clocks emerged. These were massive iron machines, whose only purpose was to strike a bell. The power source was simple, a falling weight turning a drum. But unchecked, the weight would just fall. The true genius lay in the mechanism that regulated its fall into steady periodic ticks. This was the escapement. The earliest version, the Virgin Foliot, is brilliantly simple. An escape wheel, turned by the weight, is caught and released by two small plates on a vertical rod, or verge. This push-and-catch motion creates the tick-tock, with each tick representing a small, controlled release of energy. This is why the mechanical clock is so profound. You could say it was the first digital device in history, breaking the smooth analog flow of time into discrete countable beats. Early clocks weren't very accurate, but that wasn't the point. Their very existence was world-changing. The clock detached time from nature and turned it into an independent mathematical quantity. The chiming of the town clock began to regulate civic life, creating a synchronized society essential for the rise of science, finance, and industry. You can't have the Industrial Revolution without a precise way to measure time. And that is why the mechanical clock is on this list. While an atomic clock is infinitely more accurate, the medieval clock wasn't just an invention that told time. It was an invention that created our modern concept of time. For fundamentally restructuring human consciousness, its impact is quite literally unbeatable. We're halfway through our journey, and what we've seen so far proves this era was anything but dark. These weren't disposable solutions, they were timeless extensions of skill and a deep understanding of the forces of nature. Hit like if this medieval ingenuity blew your mind, and let me know in the comments, which of these inventions surprised you the most? Honestly, I love knowing who's out there questioning how much we've really advanced. Your support helps us continue to challenge the stories we've been told and bring these incredible histories to light. Now, back to the countdown. The number one invention didn't just change how people worked, it represents a level of technological sophistication that remains an unsolved mystery to this day. The Gothic rose window. We arrive at number one with a technology so advanced, so mathematically perfect, that modern architects still struggle to replicate its genius. It's not a weapon or a tool, but something far more profound. The art of turning stone into light. Stand in front of Notre Dame, Chartres or Sainte-Chapelle and look up. What you're seeing defies everything we think we know about medieval capabilities. Massive circles of stone and glass, some over 40 feet in diameter, that seem to float impossibly in walls that should have collapsed under their own weight. The engineering challenge was staggering. How do you cut a giant hole in a load-bearing wall without bringing down the entire building? How do you support thousands of pounds of intricate stonework in a perfect circle, using only hand tools and mathematical intuition? The solution required understanding structural engineering, geometry, optics, and material science all at once. Medieval architects didn't just cut holes and hope for the best. They developed an intricate system of stone ribs, tracery, and buttressing that distributed weight with mathematical precision. Here's what makes this extraordinary. Each rose window is essentially a giant stone computer, calculating and redistributing structural forces through pure geometry. The tracery patterns aren't just decoration, they're load-bearing mathematics carved in stone. Every curve, every intersection point is precisely calculated to handle stress while allowing maximum light penetration. But the real genius was in the glass technology. Medieval craftsmen created colored glass, so chemically perfect, so optically pure that we still don't fully understand their techniques. The blue glass of Chartres contains traces of cobalt, processed in ways that modern chemists are still trying to reverse engineer. The windows weren't just beautiful, they were light amplifiers. Medieval architects understood that different colored glass had different optical properties. They arranged these colors in patterns that didn't just tell religious stories, but actually manipulated how light behaved inside the cathedral space. Modern architecture has steel, concrete, and computer modeling, yet we build with materials that corrode, crack, and require constant maintenance. Meanwhile, rose windows built 800 years ago still function perfectly, still transform light into something transcendent, still leave modern engineers wondering exactly how they were made. The Gothic rose window represents the absolute pinnacle of what humans can achieve when mathematical knowledge, engineering skill, and artistic vision combine. It's not just a window, it's proof that the medieval mind could turn the laws of physics into poetry. And here's the ultimate testament to its perfection. When Notre Dame burned in 2019, the rose windows survived. 8 centuries of weather, war, and revolution couldn't destroy them. But it took modern restoration techniques and millions of dollars just to clean them properly. In an age obsessed with digital displays and LED screens, the rose window reminds us that the most advanced screen ever invented was made from sand, fire, and medieval genius. It required no electricity, produced no waste, and created beauty that has inspired humanity for nearly a millennium. That's technology we still can't beat. Flying buttresses. From machines that multiplied destructive force, we moved to a place that commanded the elements of architecture itself. Look up at the ceiling of a Gothic cathedral. Then look at the walls, which seem to be made more of glass than of stone. What is holding all this up? For millennia, the iron law of architecture was that height required thick, heavy walls to counter the immense outward push, the lateral thrust of a stone roof. This meant buildings were inevitably dark and fortress-like. But Gothic architects had a revolutionary vision. Churches that soared, filled with light. To do that, they had to solve the problem of lateral thrust while making the walls virtually disappear. The solution was one of the most elegant and visually stunning innovations in human history, the flying buttress. The mechanism is brilliantly simple. The buttress acts like a bridge for force. It catches the immense outward pressure from the roof, leaps across open space, and channels it away from the wall and down into a massive pier, safely rooted in the earth. It's an external skeleton. That right there is a game changer. Freed from supporting the roof, walls could become thin curtains of stone and vast expanses of stained glass. This is what made the magnificent windows of Notre Dame and Chartres possible. And here's what makes this even more remarkable. The stone pinnacles that often top the piers weren't just decorative. Their weight pushed the pier more firmly into the ground, making the entire system even more stable. This was a perfect marriage of art and engineering, born not from convenience, but from pure, relentless necessity. Modern buildings use steel frames and reinforced concrete, but the Gothic cathedral did it with stone and an almost unbelievable understanding of physics. We don't often build with load-bearing stone anymore, but the principle of externalizing structural support is a cornerstone of modern design. The flying buttress solved an ancient problem with such genius that it turned structural necessity into a breathtaking display of lightness and grace. The astrolabe, the original analog computer. We now move from the colossal scale of cathedrals to an object you can hold in your hand. But don't let its size fool you. This device was a smartphone, GPS, calculator, and clock, all rolled into one intricate package of brass, the astrolabe. The problem it solved was fundamental. How do you translate the complex three-dimensional sphere of the sky into a practical, portable format? How could you create a tool to solve complex astronomical problems without tedious calculation in a world without batteries or software? The solution, perfected in the medieval Islamic world and introduced to Europe, is a marvel. It is in essence a two-dimensional working map of the heavens. It has a body, the mater, engraved plates for different latitudes, and an intricate rotating star map called the Rete. Its name means star taker. By holding it up and sighting a star with its ruler, the Alawide, you could determine the star's altitude. This one measurement unlocked a universe of information. By rotating the reading to match, you could instantly tell the local time, day or night, determine your latitude on Earth, or even survey the height of a distant mountain. For sailors in the Age of Discovery, simplified versions like the mariner's astrolabe were vital tools for navigation, used alongside quadrants and other instruments. So, why can't we beat it? Because as an analog computer, its sophistication and utility were unparalleled for over 1,000 years. It's a physical embodiment of complex mathematics, solving problems of spherical trigonometry with its own mechanics. It's a computer that needs no power and has no software to crash, built from metal and intellect. When you hold a smartphone and open a stargazing app, you are holding the direct digital descendant of the astrolabe. It represents a level of scientific mastery that utterly shatters the myth of a dark age. Conclusion. From the civilization-building heavy plough to the knowledge-democratizing eyeglasses. From the sustainable genius of the three-field system to the wind-harnessing post-mill. From the satellite-free navigation of the magnetic compass to the raw power of the trebuchet. From the gravity-defying grace of the flying buttress to the pocket-sized universe of the astrolabe. From the time-controlling mechanical clock to the light-transforming perfection of the Gothic rose window. These 10 inventions are powerful rebuttals to the lazy caricature of the Dark Ages. They show us an era of vibrant innovation where thinkers, armed with little more than their own intellect, solved profound problems with staggering genius. Their work laid the foundations for our time, shaping everything from our cities to our very perception of reality. The past isn't a dark monolithic block. It's a place filled with light, with ingenuity, and with lessons that still resonate. It reminds us that human creativity is not confined to any single period. So, which of these timeless technologies do you think had the biggest impact? Let us know in the comments below. Thank you for joining us. If you enjoyed uncovering these marvels, give this video a like and subscribe for more explorations into the history you were never taught in school. Until next time, keep questioning and keep exploring.